Hey folks, what's up? In today's video, we're going to see about what is actually dynamic programming, what are its implementations, and how we are going to actually approach a problem. So without any further ado, let's get started. And before that, if you're new to our channel, do hit like, share, and subscribe. Till then, stay tuned. So now let's look on what is actually dynamic programming concept. As we all know, dynamic programming concept tells us like we have a bigger problem in where we divide it into smaller sub problems and solve the smaller sub problems individually in order to get the result of the final output or the bigger problem. As you can see here, F5 is the bigger problem and we individually divide it into smaller sub problems such as F4 and F3, which indirectly again recursively divides it into F3 and F2, and finally it goes into a terms where F2 is further divided into F1 and F0. So once we get the solution for the smaller problems, in this case it is F1 and F0. So once we get the solutions for them, we get the solution for F2. And once we get the solution for F2 and F1, we get the solution for F3. And similarly, when we get the solutions for the sub problem, we combine them and we devise or we get the solution of a bigger problem, and finally we get the solution of the actual bigger problem, that is F5 here. And this is how the dynamic programming problem is actually approached or solved. So let's now understand what are the three main keys or properties that we need to learn actually to solve and identify any of these dynamic programming problems, right? So let's consider the first point, that is optimization over recursion. So what it actually means is that, let's go to here, right? We have a bigger problem, we can see F5. Now it is divided into smaller sub problems like F4 and F3, but you can see a thing like F3 is computed here and again F3 is being computed here. Why to compute the problem two times or more times? That is why it is giving a stress, like we need to optimize over recursion. As we know, like we're dividing each problem into sub problems and it is a recursive tree, we are using recursion here, but we don't need to compute a sub problem again and again. This will only increase the time complexity and difficulty of the solutions that we have devised, right? So we need to do an optimization. How we can do an optimization? We can either store it in a 2D array, or we can use a 3D array or a 1D array depending upon the problem we have in DP, right? So instead of computing each and every subproblem again and again, we can just store this F3 value here. Let's say this has a F3 value, and if in the next near future we need that, we'll directly get this value from this array or this data structure. We don't need to compute it again and again by solving it recursively, right? So this is how the first statement is justified, right? And the second statement says like solving sub problems to solve a bigger problem, as we have discussed in the previous videos and the previous part as well. Like we solve the sub problems, in this case it is F1 and F0, to get the value for F2. This is how we identify, right? If we are solving and if you are getting a bigger problem that we don't have an idea of how to solve, we go for solving it again and again. And this is how we like justify the second statement, right? And then we have a third statement like avoid solving the same problems again and again, that is similar to optimizations, right? We don't need to solve it, as in this case there is F2 here, you can see F2 here, it is F2 again, it is F2. So there are three F2s, we don't need to solve it three times, we can just keep it here, and every time we need we can just get it from this data structure, right? And another point that I'm going to add here is um, like we should have a overlapping sub problem. That is the main thing. Like we need to identify, like if at all we need an optimization here, because the main thing is that when we recursively solve, we need to actually have an insight like whether this recursive tree will generate a sub problem again and again. So instead of computing again and again, we can just store it and return it from there. So this is how we do an optimization, and doing an optimization over this recursion is indirectly termed as dynamic programming. So this is how dynamic programming is, and it is solved, and these are the most three vital things that you need to remember to solve any DP problem. So till now we have observed a bit about the dynamic programming history, its theory, everything, right? The three major things or the three key properties that we need in order to solve any dynamic problem. We have also discussed that, but it isn't enough, right? In order to approach dynamic problems, we don't only need theory, but we also need a hands-on practice and implementation techniques in order to solve the dynamic programming problems. So in the next video, we'll be learning how we can use the current theory that we have used in order to solve the dynamic programming problems. So till then, stay safe, stay tuned, and see you in the next video.